All right, today we're going to pull back the curtain on a seriously powerful tool. It's been hiding in the Java development kit for years, just waiting to supercharge your code. It's called the Spliterator, and it could totally change how you handle large amounts of data. But first, think about this for a second. Is your Java code really built for the world we live in now? You know, the multi-core world? I mean, we all write loops to process our collections. But what if the way we've always done it is leaving a ton of performance on the table? What if your code is only using a tiny fraction of the power your hardware actually has?
Okay, so to really get what's new and exciting here, we've got to start with the classic, the tool we all know and use every single day, the standard Java iterator.
You know it. You've used it a million times. It's pretty much the bedrock of collection processing in Java, and it does one thing, but it does it really reliably. It steps through a sequence, element by element, one by one. Simple, predictable, and totally sequential.
And right there is the problem. That one-by-one approach was fantastic back when our computers basically had one brain, a single core to think with. But that's just not how our machines work anymore.
And that's the big disconnect, right? Your code, when you're using a standard iterator, is basically stuck walking in a single file line. But your processor, it's a multi-lane superhighway. And with that old iterator, most of those lanes are just sitting empty. You're not using the power you paid for. So this is the exact problem that the Java engineers set out to fix. And that's where our hero of the day comes in, the Spliterator.
And this isn't some dusty old feature from the dawn of Java. Nope, the Spliterator was intentionally added in JDK 8 as a modern solution for modern hardware. It was designed from the ground up for this multi-core era.
So what is this thing really? Well, at its heart, it's a lot like an iterator, but with one massive difference. It's built for teamwork. It's designed for parallel traversal. And this really gets to the heart of it. On one hand, you've got the classic iterator. It's like a single conveyor belt, processing each item one after the other. But the Spliterator, oh, that's completely different. It's more like a distribution hub that can split the work across a whole bunch of high-speed lanes at once. That's the game changer. Sequential versus true parallel processing. Okay, so let's talk about this parallel superpower, because this is really the main event. This ability to work in parallel isn't just a nice little feature. It's the whole reason the Spliterator even exists. And the secret, well, it's right there in the name. Spliterator. It can be split. Look, imagine you have a giant book you have to read. The old iterator way is like one person reading it from the first page to the last. The Spliterator way is like tearing the book into chapters, handing a chapter to each of your friends, and having everyone read their part at the exact same time. That's the big idea, and it's what powers things like Java's parallel streams. So here's how that whole divide and conquer thing actually works. You start with just one Spliterator for your entire collection. Then you call this magic method, try split. What that does is it breaks off a chunk of your data and hands you a brand new Spliterator just for that piece. Behind the scenes, the Java frameworks can just keep calling this method over and over, creating these perfectly sized chunks of work that can be processed at the same time across all your different processor cores. But, and this is the really cool part, the Spliterator isn't only for all that heavy-duty parallel programming. It actually has some nice perks even if you're just writing simple, single-threaded code. See, it actually gives you a more streamlined way to iterate. Instead of the old two-step of checking has next and then calling next, you get methods like try advance that combine both of those into a single, clean, and efficient operation. It can make your code look a lot more modern. Okay, so after all that, the big question is probably, when should you actually be reaching for this power tool in your own projects?
Here's the quick and dirty guide. Number 1, and this is the main reason, you're processing huge data sets. If you have a massive collection and you want to chew through it as fast as possible, using a Spliterator, usually through the Streams API, is how you're going to unlock the full performance of your multi-core machine. And reason number 2, like we just saw, is when you just want to write cleaner, more modern iteration code, even if it's not running in parallel.
So really, the big takeaway here is that the Spliterator is so much more than just another iterator. It's a whole new way of thinking. It's about leveraging the full power of the hardware you already have. So I'll leave you with this. The next time you're about to write a loop over a big collection, just stop and ask yourself, could I do this in parallel? And what new doors would that speed open up for my application? It's a powerful question, all thanks to this hidden gem in the JDK.